What if an AI could do more than just solve problems we already know how to solve? What if it could actually venture out into the unknown and discover entirely new mathematics? Well, today we're diving into AlphaEvolve, a really groundbreaking tool that's partnering up with human intuition to take on some of the most complex, long-standing challenges in math. And I want you to really think about this question for a second. We're not just talking about some kind of calculator on steroids here. This is a profound shift. What if an AI could actually wander through the vast, uncharted landscapes of mathematics and find brand new ideas, new structures, things that have had us humans stumped for decades? It would completely change the game of discovery itself. And this is the tool that's making it happen, AlphaEvolve. It was co-authored by the legendary mathematician Terence Tao, so you know it's the real deal. This isn't just another language model. It's an evolutionary system designed from the ground up to find these complex mathematical objects and crack open problems. It's kind of like a whole new kind of research partner for mathematicians. So what is this new math quest all about? Well, it's about giving mathematicians a new superpower to tackle a very specific but incredibly important kind of problem. The paper calls it constructive mathematics at scale. So what does that actually mean? It means you can now set up and explore these huge, complex problems with way less effort. Before, a mathematician might spend months just designing a search for a solution. Now, they can basically describe the problem in just a few hours and then let AlphaEvolve go to town exploring all the possibilities. It's like giving every single researcher their own superpowered assistant. Okay, so how does this thing actually work? This is where it gets really clever. It's a beautifully simple idea that mixes the creativity of a language model with the raw power of evolution. At its heart, AlphaEvolve is just a simple two-step loop that runs over and over. First, you've got a large language model acting as the generator. It's the creative part, constantly writing and tweaking little computer programs that are its best guess at a solution. Then you've got the evaluator, which is the tough critic. It runs every single one of those programs and gives it a score. The best scoring programs, they get to survive and inspire the next generation of code. It is literally natural selection for computer programs. And right here, this is the secret sauce. This is the huge innovation. See, older systems would try to evolve the final answer itself. AlphaEvolve does something way, way smarter. It evolves a program that finds the answer. Think about it this way. Instead of just randomly digging all over an island hoping to find treasure, AlphaEvolve is busy creating better and better treasure maps. It's evolving the search strategy itself. And just to see just what a leap forward this is, you just have to look at how it stacks up against its predecessor, FunSearch. FunSearch, it could only evolve these tiny little Python functions, right? AlphaEvolve can evolve entire, complex code files in pretty much any language. As you can see here, it's just playing on a completely different level, handling more context and tackling way more complex problems. So, okay, that's the theory, and it sounds amazing. But how does this thing actually perform when you throw real, tough mathematical problems at it? Let's take a look. Now, the researchers didn't mess around. They didn't just cherry-pick one or two problems where they knew it would work. They threw a true mathematical gauntlet at it. 67 different problems. And these weren't from just one little corner of math. They covered combinatorics, which is all about counting and arranging things, geometry, shapes in space, and number theory, the study of whole numbers. This was a serious stress test of the system's power and its versatility. Let's zoom in on one really cool example, the Kakeya problem. So imagine you have a needle and you want to rotate it a full 360 degrees, but you have to do it within some defined area. The big question is, what is the absolute smallest possible area you need to pull that off? It sounds so simple, right? But it's a notoriously difficult problem that has deep connections to all sorts of other fields, like signal processing. And this is where my mind was just blown. The paper points out that AlphaEvolve found these solutions with deep number-theoretic properties that it was never told about. The AI wasn't just putting together puzzle pieces it was given, it was uncovering fundamental, hidden structures in mathematics all on its own. And the results? They were absolutely stunning. The AI discovered new and improved constructions for the Kakeya problem, basically pushing forward the frontier of what we knew. But even more impressive, sometimes its weird suggestions acted like a creative spark for the human researchers, inspiring them to write entirely new papers based on the AI's unique insights.
But, it's really important to keep things in perspective. The researchers are very clear that AlphaEvolve is not some kind of magic bullet. It's amazing at what are called optimization problems, where you can sort of hill climb your way to a better and better score. But for problems that need that one single brilliant aha moment with no obvious path to get there, yeah, it's probably not the right tool for that job.
So AlphaEvolve is fantastic at spotting these really promising patterns. But here's the thing about math. A discovery is just step one. You absolutely have to prove it. And this is where the whole story gets even more futuristic. The researchers didn't just build one tool. They built an entire AI pipeline, like an assembly line for mathematical truth. It's incredible. First, you have AlphaEvolve, the discoverer, finding a promising pattern. Then an AI named DeepThink steps in. It's like the brilliant writer, generating a formal proof that a human can actually read and understand. And finally, AlphaProof acts like the world's most meticulous editor, translating that proof into a format that a computer can check, guaranteeing it's logically perfect. What this all points to is a future where the entire scientific process, from that first creative spark to a rock-solid proof, all the way to a verified result, could be massively sped up by AI. I mean, this could fundamentally change the pace of discovery as we know it. So this brings us to the really big question, right? Does this mean the end of the human mathematician? And the paper's answer is a loud, clear, resounding no. Not at all. It's the beginning of a whole new kind of partnership.
The research really boiled down to a few key lessons. First, human expertise is absolutely crucial. The best results always came when a human expert gave the AI little hints and nudges in the prompts. Second, you have to watch out for the cheating AI. It's so good at optimizing that if you're not careful with how you set up the problem, it'll find some clever loophole to exploit. So ultimately, this isn't about replacement, it's about collaboration. It's human intuition plus the AI's incredible search power.
And I absolutely love this quote from the paper. It just shows that using these powerful AI tools is a skill in itself. The researchers found that, just like learning any new craft, they got better and better at prompting the AI and guiding its search over time. So this isn't about replacing humans. It's about giving them an incredibly powerful new instrument to learn how to play. And that just leaves us with this one fascinating thought to chew on. If this new partnership, this team-up between human creativity and artificial intelligence, can start to crack open some of the toughest problems in pure mathematics, what other fields are next? What other grand challenges in science, in engineering, in medicine could we solve when we combine our minds with machines like this? The possibilities are just really, really exciting to think about.